Hello scholars, it's Science Time with Mr. Alan and I'm glad to host you on another segment, and today we'll be looking at a very interesting topic. So let's take a voyage to the topic heat energy. We are looking at heat and temperature as a broad unit. Remember, we've treated heat energy as a form of energy that can be transformed from one form to another. We also treated forms of energy conversion, and today is a consolidation on the previously treated topic. We'll be looking at heat and temperature. So it's a very important aspect of science that we also need to look in-depthly today. Heat is thermal energy transferred from a hotter system to a cooler system. That is to say, there are systems at different temperatures that are in contact. So heat is actually a form of energy and we call it thermal energy. It is transferred from a hotter system to a cooler system, which means there must be a difference in temperature between the two bodies in contact that the transfer is taking place. Remember, we said in the first law of thermodynamics that energy can neither be created nor destroyed, but can be transformed from one form to another, which means different forms of energy can be changed or can be converted from one form to another, as we saw in the last week's presentation. Having said that, I'll take you to the next slide. Heat is transferred in three major ways. We have convection, conduction, and we have radiation. Now this is what we call heat transfer in science, and what that simply means is that we have different forms of matter, solids, liquids, gases, and plasmas. When there is direct contact between a solid, be it metal and so on, with the source of heat, and the heat is transferred in order to cook or fry whatever is inside a frying pan, we call that heat transfer conduction. It's a transfer of heat in solid objects or substances. Then the transfer of heat that happens in liquid, mostly in fluids like liquids, where heat is transferred from the source to the body of a kettle or a pot or a frying pan to the fluid inside the frying pan. In this case, maybe let's say vegetable oil. The oil gets hot and begins to fry up the food in it. We call that heat transfer convection. Then the third phase or third type of heat transfer is what we call radiation. The heat from the frying pan gets to your palm, like when you try to feel it from a distance without any direct contact. If you observe in this picture, the arrow shows the direction of heat rising up to fill up the whole kitchen or the atmosphere where this frying is going on, and you can feel the heat from a distance without having a contact with it. So heat transfer without having any direct contact with the element or the objects is what we call radiation. A very good example of this form of transfer is the transfer of heat and light energy from the sun, which is solar energy. Now, solar energy, when it burns hydrogen and helium gases, produces light and heat, and it reaches the earth in 8 minutes. So the vacuum or the space which the heat and the light passes through to reach the earth is what we call radiation. And we can also call the solar energy radiant energy from the word radiation. So summarily, heat is transferred through solid objects in form of conduction, through liquid objects or substances in form of convection, and through vacuum or space in form of radiation. Okay, having said that, this is another picture, laying more emphasis on heat transfer. If you look at this picture here, you have a pot on a cam gas which supplies the heat. The conduction here is quite crystal clear, as you can see. The handle of this pot is made of metal. As you can see, there's a form of heat transfer going up to the handle because it's made of metal. But objects made of wood will not allow heat to pass through because they are not good conductors. So the transfer of heat from this cam gas as a source to the handle is called conduction because it's passing through a solid body and you can feel it with your palm with a sense of touch. Then for convection, if you observe, there's a liquid or whatever is boiling inside this pot. The heat from the cam gas or the source does not have a direct contact with it. It only passes through the body of the solid, which is the pot, and heats up the food or substance in it. That process is called convection, form of heat transfer. Then if you observe, there are arrows emanating from the source of the heat, and it engulfs the whole room where this activity is going on, where you begin to feel the heat from every corner of the kitchen or the room where you're cooking. In this case, that heat was transferred from this point to the entire room through radiation, and it has to pass through space or vacuum in the room. Okay, having said that, if you look at temperate areas where the weather is extremely cold, they have a lot of fireplaces built as part of their houses to keep the house warm. This explains heat transfer also. Fire burns the wood and forms charcoal and later ash. The heat transmits through the wood and burns into ashes. That's conduction. Then convection is when this heat begin to dissipate within this space called the fireplace, and eventually we begin to feel the warmth or the heat from this fireplace in the entire room through convection heat transfer. I have another picture of a camp gas. A camp gas will always supply heat. A camp gas is filled with cooking gas, and cooking gas is used to prepare our foods to make them edible. So heat is very important because it helps to prepare and cook our foods, and our foods are ready for consumption. Heat from this camp gas will eventually travel around the metal ring at the top of the cylinder through conduction. Then convection is when you have maybe a kettle on it and you're boiling water. The water after some time receives heat and begins to boil at the boiling point of 100 degrees Celsius or centigrade through convection. Then at some point you start feeling the heat across the entire room, and that is transfer of heat through radiation. So these are the three major methods through which heat is transferred. So we're looking at temperature. Like I said earlier, we're looking at heat and temperature, the relationship between heat and temperature. Temperature, on the other hand, is a measure of the amount or degree of hotness or coldness of a body. How hot or cold a body is. When we say a body, it could be a solid, a liquid, or even gases. When you heat up gases, they also receive heat and begins to move in a random motion from one point to another, and they collide with the walls of their container. Temperature is also seen as a measure of the average kinetic energy or molecules in a body. What that simply means is that heat will eventually lead to either the rise or the decrease in temperature in a particular room or closet. Like we said, heat is a form of energy, and it's a thermal energy that is transmitted from a hot body to a cold body. While that process is happening, we say there is temperature rise or temperature decrease. So I'll go further to explain this. Temperature is simply how hot or cold an object is. As you can see, this is a solid body. Now when heat is applied, the temperature will increase, and if the heat is applied from this point, for instance, the heat will travel through conduction from here, going all through the middle, and before you know it, it will circulate the entire solid object. So that is just the effect of heat. Then when we look at the difference between the source of heat and the point where the heat was not supplied, we say there's a difference in temperatures, and that's what leads to the transfer of heat through conduction, convection, and radiation. Heat and temperature has a very close relationship, and I'm going to be treating that in the subsequent slide. So heat is transferred to the object. Example, stove heats pan. When you put pan on stove, it will heat it up, and probably if you're boiling water or cooking food, after some time the food or water will gain heat, the temperature will rise, and it starts boiling until you are ready to use it, and it continues that way. Okay, now let's look at the relationship between heat and temperature. These are very important phenomenon in everyday life because we can't do without heat supply, especially in our homes, our kitchens. Then in industries, heat is used in production processes. Like we said in our previous classes, a lot of production process cannot go on without the application of heat. In our bakeries, the oven supplies heat in order to bake the bread in the pan and make it ready and edible for eating. Heat is used to move our automobiles. Heat in automobiles is generated when the engine is ignited and combustion takes place by burning the chemical energy in the fuel to power up the electrical components of the automobile or even the moving train. Like coal supply heat for some train to move, and coal energy is also transformed to electrical energy when it heats up a steaming turbine, and the fossil energy in the coal or the heat supplied is converted to electrical energy. So heat and temperature is quite a very important phenomenon that we cannot do without. Their importance cannot be overemphasized. Temperature goes as far as determining how well an individual is. Because if your body temperature falls below normal, which is 37 degrees Celsius, or goes above it, then it's an indication that such an individual is probably sick or infected with a particular infection and might need the services of a medical personnel and so on. So having said that, let's look at the relationship between heat and temperature. As you can see in this picture, heat is supplied from different sources. Then temperature as in a thermometer here. Okay, so temperature is measured with an instrument called the thermometer in a unit known as degrees Celsius or degrees centigrade, and it is represented with this symbol superscript 0 and capital letter C. The other units are degrees Fahrenheit, that's superscript 0 and capital letter F, and Kelvin. So we have different scales for measuring temperature, as you can see in this case. Alright, while heat is measured with an instrument called calorimeter in joules, and joules is actually the unit for measuring energy. And the reason why we're measuring heat in joules is because heat is a form of energy. So a major relationship between them is that heat will always lead to the rise in temperature or fall in temperature, but they are measured in different units using different instruments, as you can see. So while heat is measured with a calorimeter in joules, temperature is measured with an instrument called thermometer in degrees Celsius or centigrade. So furthermore, heat and temperature are two different but closely related concepts. I want you to note that they have different units. Temperature typically has units of degrees Celsius or Kelvin, as I said earlier, and heat has units of energy in joules. Okay, I'll move further at this point to show you the instrument. This is a picture showing a calorimeter, and this one looks complex, but they all perform the same function to measure the heat of a body. We have a simple calorimeter, as you can see here. Then we have this picture showing thermometers of various kinds. Here we have the infrared thermometer, here we have the mercury in-glass thermometer, here we have the digital thermometer, and also we have the dry bulb thermometer. They are all used to measure different temperatures. Then the calorimeter measures different heats that emanate from different bodies. Okay, having talked about the relationship between heat and temperature, let's move on to identification of different types of thermometers. And we're doing this because we have different types of thermometers that are used based on purpose and based on the environment. Following this assertion, we're looking at the first one here. Is called mercury in-glass thermometer. It is called mercury in-glass thermometer because the thermometer is made up of a glass tube that is filled up with mercury. Mercury is a sensitive metal that is sensitive to temperature, be it hot or cold. So it has a sensor. As soon as the tip is in contact with the substance or the sample you want to observe the temperature, the mercury moves this way, all the way up, and stops at a point on the calibrated mark. We call it graduation or calibration. So anywhere the mercury stops, you take your reading. Like in this case, this thermometer is made up of both the degrees Celsius and the degrees Fahrenheit scale. So you can choose to use the degrees Celsius scale. It can be converted from one scale to another. So for degrees Celsius, this would be 20 degrees Celsius of this particular temperature. Then for Fahrenheit, this will be 70 degrees Fahrenheit because it's calibrated into interval of 10, so we call it appropriate scaling. So the scaling here is 20, we have 20, 40, 60. So between 60 and 80 you have 70, so this will be 70 degrees Fahrenheit, while this is 20 degrees Celsius. And this particular thermometer is used to measure the temperature of different samples or substances in a laboratory setting. For example, when you want to measure the temperature of a cold or hot water, or even some chemicals in the laboratory for experiments, you just dip the sensor into the sample a bit, then you allow the mercury to rise, and anywhere it stops, you take your temperature reading. Okay, having said that, I go to the next one. We have what we call the clinical thermometer, and it is called clinical thermometer because it is used in the hospital environment. That's by a medical practitioner in medical practice to check the body temperature of patients before administering treatments. So it is used in the hospital to check the body temperature of patients. As you can see here, this is a digital clinical thermometer. They tend to place it in the armpit or in the mouth of the patient after disinfecting with a disinfectant that is alcohol based. As you can see here, it is used in contact with the mouth, and the temperature is read on the temperature reading scale. Though medical practice is gradually moving away from the use of these thermometers because even though they are being disinfected before usage, they are trying as much as possible to avoid direct contact of instruments with patients because of some infectious or transmissible diseases, as the case may be. Alright, I move to the third type of thermometer here. It's called the dry bulb thermometer. In this case, you have the dry bulb with mercury in it, and the mercury sends signal as it rises up to the mark for measure different temperatures of the sample you're trying to measure. So it's also used in scientific laboratories to measure the temperature of some substances. The space between these fixed points is broken up into divisions called degrees. So if you have 20 degrees here, you have 40 degrees, and you have 60, 80, 100, and it keeps going based on the calibration of the thermometer. So that's the dry bulb thermometer. Then we have the infrared thermometer. This is the most advanced type of thermometer that is used for measuring body temperatures of individuals or patients at work, at home, or in hospitals, etc. Now, you discover that this is the most advanced because it doesn't require a direct contact with the patient's body, as in the case of a clinical thermometer used in the armpit or the mouth. It's just the infrared rays sensitive to temperature, and it sends the signal or the reading to the digital surface where you take your reading. As in this case, you have 36.5 degrees Celsius. It doesn't involve a direct contact. And with the current novel coronavirus ravaging the world, you can see a lot of organizations, even schools, banks, and other parastatals or hospitals tend to use this infrared thermometer to get the temperature of patients to know if they are infected with the coronavirus or not. Because when there's temperature increase, it tells that the patient might be having some feverish condition, which is a symptom of the novel coronavirus called COVID-19. Okay, so it is the most advanced, and I think I will go with this when it comes to taking my temperature because of contact and trying to avoid the transfer of communicable diseases. So with that, we come to the end of this lesson, and summarily we've been able to learn what heat is all about, temperature, and how to relate heat and temperature. We've seen the units used in measuring heat, which is joules, and temperature, degrees Celsius or centigrade, or the Kelvin or Fahrenheit scale. We also learned the types of thermometers. We looked at the mercury in glass thermometer. We also looked at the dry bulb thermometer. We looked at the infrared thermometer. And lastly, we talked about the mercury in glass thermometer. So let's keep exploring more on heat and temperature and how it relates to everyday life. Inspired from Mr. Alan. See you in my next episode.